Hi, my name is Nick Walker, and I'm a product manager here at StormForge. Today, I'd like to show you a little bit about our product Optimize Live. One, we're going to talk about how you can gain top-down visibility on all your Kubernetes workloads, and how you can view and verify those recommendations for any given workload. And finally, how you can configure guardrails and settings to give you confidence that the recommendations are right for your organization. So first, getting started, you will add a cluster. You'll install the agent in a cluster using a Helm command provided here. And after that agent is installed, it'll send up metrics, which allows us to produce a recommendation summary like you see here. So we can tell you the current requests you have configured for CPU and memory, as well as what they would be if you accepted all of our recommendations. So you can see we've got about $296 savings, but that's not the whole story. As we expand this, we can see that there is a whole lot of over-provisioned workloads, and also there are under-provisioned workloads. And the fact that these are under provisioned provides a liability for you. So when we scale these up, we improve the performance and reduce the chance of any outage caused by these workloads being under provisioned. And that's a great benefit that you get in addition to the waste that we're reclaiming by sizing down over provisioned workloads. And you can also see that on this page, we're showing you the top offenders at each level. Now we can move on to looking at a specific workload. So this is just a front-end workload in a demo app that we have. You can see you get a similar summary up top of where you started and where you would be if you accepted the recommendation. And on the graph here, you can see that it is graphing the usage in the bottom in blue. And then we're graphing both the recommended requests as well as the current requests. And you can see everything's going up and down over time as the replicas scale up and down because this workload has an HPA on it. And if we scroll down to the memory, we can see that there is a lot of waste here. We can actually remove the current just to see how the usage compares to the recommended because the current is so far away that it's hard to see. And now we can come over to the recommendation details. On this page, we see that the graph is showing us average usage across all the replicas. So you don't have as much up and down, and it's a little bit easier to see how the usage compares to the recommendation as compared to the other graph. And so now that we've looked at these graphs, we can see that the recommendations make sense against the current usage. And we can also see here that our recommendations include changing the HPA target utilization. And that is so that as we scale the vertical sizing up or down, we can also change that target utilization to keep your scaling behavior the same. So you don't have to worry about that changing as we right size your workloads. Now that we've seen all this, we may want to apply these recommendations to a specific workload. And the easiest way to do that is to hit the Apply Now button here. All you need to do that is install the implier component in your cluster, but that does require write access. And so if you're not ready for that, you can come over here and look at your patches. You can download them and go ahead and apply them via kubectl patch. Or if you'd like, you can use this information and run it through your GitOps workflow to apply it that way. So now that we've seen that, we can move on to looking at settings and guardrails. First, we have our setting called optimization goals. And you can see that this allows us to bias the machine learning towards savings or towards reliability. So what we often see is that users will set this to savings and non-prod and use it a little bit more towards reliability in production environments. However, the balanced approach is relatively conservative as it is. So we also have automatic deployment. So long term, your goal is going to be to use automatic deployment to continually right size your workloads. And a nice feature we have is that when the changes between recommendations are small, you can configure thresholds to make sure that we don't apply small changes, which unnecessarily cause churn in your Kubernetes cluster. And finally, we have minimum and maximum bounds that allow your developers to configure minimums and maximums that make sense for their application. And this is one way that helps them gain confidence that these recommendations will fit within their workload. On the bottom, you can see we have annotation examples. So ultimately, the UI is showing you the final result of configuration that can be applied at the cluster, namespace, or workload level. So what we see is that organizations like to configure most of the settings at the cluster level to get a good baseline across all their workloads, and then sparingly change them at the namespace or workload level as needed to fine-tune certain applications. The benefit of using annotations for this configuration is that it allows you and your developers to use a workflow that you're already familiar with, which is annotating objects in Kubernetes. That's everything that I have for you today. And as you recall, we saw how you can gain top-down visibility of all of your Kubernetes workloads here, how you can view and verify a patch, as well as how you can configure guardrails and settings for the recommendation behavior. Thanks.